So good morning dear students. Today we are going to start next nuclear decay. So next nuclear decay is nothing but it is beta decay. So you know that beta particles are nothing but the electrons or this positron, that is positive electron are called as beta particles. Okay, you know that the beta particles are nothing but electrons and the positrons are the beta particles. If from the nucleus these beta particles are emitting, then that type of decay is called as beta decay. Okay, the process of emission of electrons or positron during the nuclear decay is called as beta decay. In that there are two types of beta decay. There is beta plus decay and beta minus decay. Okay, in beta decay there are two processes. There is beta minus decay and beta plus decay. Then what is meant by this beta minus decay? Beta minus decay is nothing but negative particles. Here the negative particles are nothing but the electron. If from the nucleus the electrons are emitting, then that type of decay is called as negative beta decay, or it is also called as beta minus decay. If from the nucleus the positrons are emitting, that is positron, that is positive electrons are emitting, then this type of decay is called as beta plus decay or positive beta decay. Okay, in beta decay there are two processes, beta plus decay and beta minus decay. If the electrons are emitting, then it will beta minus decay. If these positrons are emitting, then it is called as beta minus decay. Now we are going to study in detail that is beta minus decay and beta plus decay. First one is beta minus decay, or it is also called as negative beta decay. So here what will happen? The electrons are emitting. So general equation is given by Zxa. So Zxa beta minus decay. Here you are getting Z plus 1 plus here this will be the electron. So this is electrons. Okay. So beta minus decay ಅಂದ್ರೆ ಏನಾಗಬೇಕು, electrons emit ಆಗಬೇಕು. electron emit ಆದಾಗ ಏನು ಬರೀತೀವಿ, E0 ಬರೀತೀವಿ, -1 ಅಂತ ಇರಬೇಕು this charge. Okay. So ಈ -1 ಏನಾಗ್ತದೆ, ನಮಗೆ ಜಾಸ್ತಿ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಡೆ ಏನಾಗಬೇಕು, Z+1 ಆಗಬೇಕು in order to balance this equation. Here it is Z is there, so here -1 is there, so it must be the daughter nucleus must be it has Z+1. So Z+1 -1 plus 1 cancels and it comes to Z, and the mass number it will remain same. So during this beta decay, negative beta decay, one more particle is emitting. That particle is called as mu anta bardu admele onde enagtave bar activity is called as anti-neutrino. This will be anti-neutrino. Okay, so during negative beta decay this anti-neutrino is formed. So when Zxa it will undergo beta minus decay, the atomic number of the daughter nucleus it will increases by 1 unit, and the mass number it will remain same. So this is called as Soddy-Fuzzel law anta kareeತಾರೆ. alpha decay hin bartivi ade riti idakku baritivi, and this particle that is called as electron, as the electrons are liberating emitting, and this type of decay is called as negative beta decay. Along with this electron one more particle is emitting, that particle is called as anti-neutrino. Okay, so it has the negligible mass compared to the electron. Okay, so example here we can see that phosphorus 15 phosphorus 32 it will undergo beta minus decay. So beta minus decay ಆದಾಗ ಏನಾಗುತ್ತೆ, ನಮಗೆ electron ಒಂದು ಹೊರ ಬರುತ್ತೆ. So electron ಬರ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಹೇಳ್ತಿದ್ದಾರೆ, according to Soddy-Fuzzel law the atomic number must increase by 1 unit. So 15 into 15 plus 1 16 ಆಯ್ತು. So 16 atomic number ಇರೋ element ಯಾವುದು, that is nothing but this sulfur ಅಂತ, that is 16 sulfur. The mass number remains same, that is 32, plus here it will be the electron and this it is anti-neutrino. Okay, now in a nucleus how this anti-neutrino is formed ಅನ್ನೋದನ್ನ ನಾವು ನೋಡಬೇಕಾಗುತ್ತೆ. This anti-neutrino is formed during the conversion of this neutron into proton. ಈ neutron ಅನ್ನೋದು proton ಆಗಿ ಕನ್ವರ್ಟ್ ಆದಾಗ ಏನು ಮಾಡ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ this anti-neutrino is formed. 1 ಮಾರ್ಕ್ಸ್ ಗೆ ಕೇಳಿದ್ದಾರೆ, ಐಡೆಂಟಿಫೈ ದಿ X ಅಂತ ನಮಗೆ ಸಮಾಸದಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. ಈಗ ಕೊಟ್ಟಿದ್ದಾರೆ ನ್ಯೂಕ್ಲಿಯರ್ ರಿಯಾಕ್ಷನ್, ನ್ಯೂಟ್ರಾನ್ ಇದೆ ಅಂಡರ್ಗೋಯಿಂಗ್ ರಿಯಾಕ್ಷನ್, ಪಾಸಿಟ್ರಾನ್ ನಮಗೆ ಪ್ರೋಟಾನ್ ಕ್ರಿಯೇಟ್ ಆಯಿತು, ಅದ್ರ ಜೊತೆ ನಮಗೆ ಇಲೆಕ್ಟ್ರಾನ್ ಕ್ರಿಯೇಟ್ ಆಯಿತು, ಪ್ಲಸ್ ಮಾಡಿ ಇಲ್ಲೊಂದು X ನ ಕೊಡ್ತಾರೆ. ಯು ಕ್ಯಾನ್ ಸಿ ಇನ್ ಯುವರ್ ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಪೇಪರ್ ಒಳಗೆ ನೋಡಿದ್ರೆ ನಮಗೆ in the nucleus when this neutron decays into proton. So neutron ಅಂತ ಹೇಳಿದ್ರೆ it is the charge on this neutron it will be 0 ಅಂತ ಆಯ್ತಾ. ಸೊ ಇಲ್ಲಿ ಮಾಡಿದಾಗ ನಮಗೆ ಇದು ನಮಗೆ ಏನಾಗಿದೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ಇಲ್ಲಿ ನಮಗೆ 0 ಚಾರ್ಜ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಡೆನೂ ಏನಾಗಬೇಕಿತ್ತು, ಸೊ ಚಾರ್ಜ್ ಮಸ್ಟ್ ಬಿ ಕನ್ಸರ್ವ್ಡ್ ಅಲ್ವಾ. ಈ ಕಡೆ 0 ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಡೆನೂ ಏನಾಗಬೇಕು, ನೆಟ್ ಚಾರ್ಜ್ ಇಟ್ ಮಸ್ಟ್ ಬಿ 0. So as the protons are positively charged, electrons ಏನಾಗ್ತದೆ they are emitting, they are negatively charged. So charge ಏನಾಯ್ತು ನಮಗೆ ಇಲ್ಲಿಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಇದೆ. ಅದ್ರ ಜೊತೆ ಏನಾಗ್ತದೆ one more particle is present, that particle is called as now anti-neutrino ಅಂತ ಕರೀತೀವಿ. This anti-neutrino has the zero mass, almost it is negligible mass, and charge on that anti-neutrino it is very charge it will be 0 and the mass is very less compared to that of this electron. Okay, this is the process of emission of this anti-neutron. One mass ಗೆ ಕೇಳ್ತಾನೆ ಯಾವಾಗ ಆಗುತ್ತೆ, inside the nucleus neutron convert into this proton, then electron is formed, electron ಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ inside the nucleus. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಇನ್ನೊಂದು ಪಾರ್ಟಿಕಲ್ ಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, that particle is called as anti-neutrino ಅಂತ ಕರೀತೀವಿ. Okay, so second is beta plus decay. So beta plus decay is nothing but the emission of positron from the nucleus. That type of decay is called as it is beta plus decay. So ಇದಕ್ಕೆ opposite ಆಗುತ್ತೆ beta minus. Here the element is represented by, so nucleus represented by ZXA, beta plus decay. So beta plus decay ಅಂತ ಹೇಳಿದ್ರೆ this particle is positive electron, that is positron ಅಂತ ನಾವು ಅದನ್ನ ಕರೀತೀವಿ. ಸೊ ಇಲ್ಲಿ ನಮಗೆ +1 ಬರೀತಾ ಇದ್ದೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ ಏನಾಗಬೇಕು, this atomic number it must conserve. ಇಲ್ಲಿ Z ಇದೆ, ಇದೇನಾಗಬೇಕು Z minus 1 ಆಗಬೇಕು. That is atomic number decreases by 1 unit and mass number it will remain same. This type of decay is called as now beta plus decay ಅಂತ ಕರೀತೀವಿ. So here you can see ZXA, beta plus decay is forming Z minus 1 HA plus 1 E0. This is called as positron and this particle is called as neutrino. So ಇದನ್ನ ನಾವು neutrino ಅಂತ ನಾವು ಕರೀತೀವಿ. So neutrino and anti-neutrino are pairs. So ಅದು ಒಂದು ಪಾರ್ಟಿಕಲ್ ಆಗಿರುತ್ತೆ, ಇನ್ನೊಂದು ಆಂಟಿ ಪಾರ್ಟಿಕಲ್ ಆಗಿರುತ್ತೆ. Okay, so example, say one example. Here you can see that 11 sodium 22. So sodium 22 ನಾವು ತಗೊಂಡಿದ್ದೀವಿ. So according to Soddy Fazal ಏನಾಗಬೇಕು, so atomic number decreases by 1 unit. ಅಂದ್ರೆ 11 minus 1 it is equal to 10 ಅಂತ. So what is 10? 10 is for this neon. So therefore 10 neon 22 plus this is positive electron, that is positron, plus it is neutrino. So how this neutrino is formed? Again ಇದಕ್ಕೆ reverse case. Inside the nucleus when proton convert into this neutron, ಆಯ್ತಾ, ಪ್ರೋಟಾನ್ ಏನಾಗಬೇಕು ನ್ಯೂಟ್ರಾನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಬೇಕು. ಆ ಕೇಸ್ ಒಳಗೆ ಏನಾಗುತ್ತೆ, this positive electron is liberated. So along with this neutrino is formed. Okay, inside the nucleus when proton decays into neutron, so proton ಅಂದ್ರೆ ನಮಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ನ್ಯೂಟ್ರಾನ್ ಅಂದ್ರೆ ನಮಗೆ 0 ಚಾರ್ಜ್ ಇದೆ. ಈ ಕಡೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಡೆ ಏನಾಗಬೇಕು, ನಮಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರಬೇಕು. Therefore the positive electron is liberated. Along with this one more particle is liberated. This particle is called as now neutrino ಅಂತ ಕರೀತೀವಿ. Okay, neutrino. Again the mass of the neutrino is very small compared to mass of this electron, and the charge of the neutrino is almost 0. Okay, so this is about this emission of this neutrino and anti-neutrino. So example ಕೇಳಿದ್ದಾರೆ, ಈ ರಿಯಾಕ್ಷನ್ ಕೊಟ್ಟು X ಅಂತ ಹಾಕಿರ್ತಾರೆ, ಐಡೆಂಟಿಫೈ ದಿ ಕರೆಂಟ್ ಎಲಿಮೆಂಟ್ ಪಾರ್ಟಿಕಲ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. Okay, so next one, the gamma decay. So third decay is gamma decay. So gamma decay is nothing but the emission of gamma photon, that is light energy, high energy light is emitted during this nuclear disintegration. That type of disintegration is called as, here it is called as this gamma decay, that is gamma photon, high energy photon is emitted. So what is the general reaction of this gamma decay? So the gamma decay general representation is ZXA, and here it is star. This star indicates that it is unstable nucleus. So that is the nucleus is in excited state alirutte. This excited state nucleus then undergoes the gamma decay and it will form the stable nucleus. This will be the stable nucleus and this will be the gamma photon. So this is nothing but the gamma photon. The packets of energy is called as photon. Okay, the emission of gamma photon from the nucleus during the disintegration is called as gamma decay. General reaction is known by ZXA star. This A star indicates that it is unstable or it is in excited state, and during this gamma decay, so according to gamma decay, it will come to its stable state and will emit the gamma photon. So ಹೇಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, so if this is one ಇದೊಂದು example ತಗೊಳ್ತೇನೆ. So here we have given the example 27 cobalt 60. This is 27 cobalt 60. So this will be the radio isotope. ಇದಕ್ಕೆ ನಾವು isotope ಒಳಗೆ radio isotope ಅಂದ್ರೆ radioactivity exhibit ಮಾಡೋ, this is the isotope. ಈ ಐಸೋಟೋಪ್ ಅನ್ನು ಏನು ಮಾಡ್ತೀವಿ, ಫಸ್ಟ್ ಇಟ್ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಟು ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್, ದಟ್ ಇಸ್ ಅನ್ಸ್ಟೇಬಲ್ ನ್ಯೂಕ್ಲಿಯೈ ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ. ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಇಟ್ ವಿಲ್ ಅಂಡರ್ಗೋ ದಿಸ್ ನೆಗೆಟಿವ್ ಬೀಟಾ ಡಿಕೇ. ಸೊ ನೆಗೆಟಿವ್ ಬೀಟಾ ಡಿಕೇ ಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೀವು ನೋಡ್ರಿ 27 cobalt 60 ಅಂತಿದೆ. ಈಗ ಬಂದಿದ ತಕ್ಷಣ ಏನಾಯ್ತು, ಇಟ್ಸ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಇನ್ಕ್ರೀಸಸ್ ಬೈ 1 ಯೂನಿಟ್. ಇನ್ಕ್ರೀಸ್ ಬೈ 1 ಯೂನಿಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ this will be the beta minus decay. So here the electrons is emitted. So ಇದಾಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, this state of nickel. So nickel ಅನ್ನ unstable nucleus ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾರೆ. ಈ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯೈ ಏನು ಮಾಡುತ್ತೆ, it must undergo this one more disintegration in order to produce the stable nucleus, that is 28 nickel 60. 28 nickel 60 ಅನ್ನೋದು ಒಂದು ಸ್ಟೇಬಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಅನ್ನು ಮಾಡ್ಕೋಬೇಕು. ಸೊ if E2 is the energy in this state, E1 is this energy in this state, so there is a difference in energy, that is E2 minus E1, so that it will produce the energy from the transition from E2 to E1. So E2 ಇಂದ E1 ಗೆ ಟ್ರಾನ್ಸಿಷನ್ ಆಗಬೇಕಾದ್ರೆ it will produces the photon of a certain energy beam. So therefore, and the formed nucleus will be, it will be the stable nucleus. This is unstable, that is excited state, it will be the stable nucleus. So okay, here you can see that 28 nickel 60 star, this is excited state, it will undergo the gamma decay and produces 28 nickel 60. So it will be stable and this will be the gamma photon. Okay, thank you.